Evidence of the Big Bang. So, considering the diagram of the wave below, I want you to come up with some definitions of crest, trough, frequency, and wavelength. Go ahead and pause this video and go ahead and try to answer those questions. So the crest of the wave is going to be the highest point, the maximum of the wave, whereas the trough is the minimum of the wave. Frequency. So this is like the number of waves that pass a given place per second. So if I were to stand and I were to count the number of waves that went by me per second, that would give me frequency. And then wavelength is the distance from two identical points on a wave. So the horizontal distance, such as between the trough and the trough, that will give you a wavelength. You could do crest to crest, trough to trough. You could do, this point to this point. That's one complete wave. Go ahead and pause this video. Take a couple of minutes to work on questions 2 and 3. So first we want to sketch a long wavelength and a short wavelength. So I've got two different waves here, A and B. Which one of these is going to be the higher frequency? Well, that's going to be the one with the shorter wavelength. If I were to stand right here and count the number of waves that go by me, more waves are going to go by me because the wavelength is much shorter. So more waves are going to pass by per second. Another way to represent waves is shown below. So this diagram here is just showing us the crests of the wave. So we're just seeing the top part of the wave in this diagram. So it's sort of like ripples in a pond. So if you took the distance between these two, that would give you your wavelength. So now you're going to want to navigate to this website, and you're going to want to progress through the simulation, making sure to follow the directions. Go ahead and pause this video until you've finished with the simulation. So we started out by having an object on the screen, and it is traveling at 30 meters per second. The wave speed is 70 meters per second, and the frequency is 1 hertz, which is 1 wave per second. So we want to press start and pause once the object is in the middle of the simulation. So we should have a picture that looks something like this. Notice that in front of the object, the wavelength becomes shortened, whereas behind the object, that wavelength becomes longer. So as this object is emitting waves, it's also moving forward. So this is going to decrease the distance between the waves, making that wavelength appear shorter. Behind the object, we have the same effect, where the object is traveling forward. So the distance between waves behind the object are going to decrease, or I'm sorry, they're going to increase, making the wavelength longer. So now we want to compare the image we just saw to what it would be if the object was traveling faster. So this one is showing us 60 meters per second, and this one's showing us 30. So looking at these pictures, you probably notice that this effect, this shortening and lengthening, is more pronounced when the object is moving faster. And that's because as the object is moving faster, the distance between the crests gets even smaller. So more distance is traveled between each wave that is emitted. So we see that the faster the object moves, the more this effect of the wavelength getting shorter or longer, the more that effect is noted. So question 6, we have two pictures here. One is showing an object flying towards Earth, and the other is showing an object that is flying away from Earth. So if the object is flying towards Earth, we would observe a wavelength that is shorter than what it would be if the object was holding still. And that's because as that object travels towards Earth, the distance traveled between waves gets smaller. If the object is flying away from Earth, we would expect to see a wavelength that is longer than what it would be if the object was holding still. So as that object travels away from Earth, the distance between waves is going to get larger. So we have that lengthening effect. So the diagram represents the wavelength of red light and blue light. So red light has a longer wavelength than blue light. When the object is flying away from Earth, are the wavelengths blue shifted or red shifted? So we know that when the object is flying away from Earth, that its wavelengths are going to get longer. So we call that red shifted. It's not that the color of the light or the waves becomes red, it's that the wavelength is getting longer, more red-like, longer wavelength. So in question 7 here, when sodium is burned on Earth, it emits light at two wavelengths. So one of these is 589 and the other is 590, and these are nanometers. So have you ever seen those orange-yellow lights that are along the side of the highway? Those are actually sodium lamps, and they contain a little piece of sodium that when you excite it with electricity, those atoms start to emit light. And the reason it has that orange-yellow color is because the wavelength of the light that is emitted is at 589 and 590 nanometers. Now, if we look at the light from a distant star, we can see that that star is still burning sodium because I see those characteristic two lines there. But what has happened to the wavelength? My wavelength has increased from around 600 to around 700. So go ahead and pause the video and take a couple of minutes to come up with some answers to question 7. So compare the wavelength that sodium emits on Earth versus a distant star. Is the wavelength red shifted or blue shifted? So we saw that that wavelength got longer. So from around 600 nanometers to around 700 nanometers. So we would call this a red shift. Now, based on the data, this distant star then must be moving away from us because its light is red shifted. So how does this support the idea that the universe is expanding? So when we look up at the sky and we look at the light from stars, no matter where we look, that light is always red shifted. So that means that everything is moving away from us. And this is actually due to the expansion of the universe. For your next journal write, you're going to summarize the concept of redshift and blue shift and how this evidence supports the theory of the Big Bang.